Welcome back. Let's do question 321. Consider the number pattern below created by using the numbers of the sequence 2, 6, 10, 14, 18 like that. So there's a constant difference of 4. Now it says calculate the sum of the numbers in the 8th row. Right, so we need to find the sum of the numbers in each row and then find what type of a sequence it is. Let's start by extending the sequence. So we have 46, 50, 54, 58 there. And then the first row is 2, 6 plus 10, 16, 14 plus 18 plus 22 plus 54, 26 plus 30 plus 34 plus 38, that's 128, 42 plus 46 plus 50 plus 54 plus 58, that's 250. Let's just discuss this a bit. I want us to start with the linear sequence. Let's say we have a linear sequence 3, 6, 9, 12. It goes on like that. Right, a linear sequence, you know that the first difference is what? Is constant. This will assist us to come up with the general term for these sums. The linear sequence, the first difference is constant. How do we find the general rule? For this one, we just say Tn is equal to 3 times n. You see that we just multiply n by 3, or the position number by 3. 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12. So we're interested in the n here. And then when it comes to the quadratic one, let's say we have numbers 1, 4, 9, 16, 25. It goes on like that. So the first difference, 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9, 7, 25 minus 16, 9. And then when it comes to the quadratic sequence, do you see that the second difference is the one which is constant? Now the position, or n, is squared. Like here, Tn is going to be n squared. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, like that. Then when it comes to the cubic sequence, let me give you a simpler one. 1, 8, 27, 64, 125. First difference, 7 there, 19 there, 27 minus 8 is 19, 64 minus 27, 37, 125 minus 64, 61. Then 19 minus 7 is 12, 37 minus 19, 18, and then 61 minus 37, 24. Then 18 minus 12, that's 6. And then 24 minus 18, that's 6. You see that it is the third difference that is constant. So if the third difference is constant, the sequence is cubic, and we'll have to somehow cube the position number, or cube n. Let's check. If we say n is equal to n cubed, 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed 125. So somehow we cube what? We cube the positions of the terms. Let's find the general rule for the sum of the numbers in the rows. So we have 2, 16, 54, 128, 250. Right, let's find the first differences. 16 minus 2, that's 14. 54 minus 16, that is 38. 128 minus 54, that is 74. 250 minus 128, that is 122. And then 38 minus 14, that is 24. 74 minus 38, that is 36. 122 minus 74, that is 48. Then 36 minus 24, that is 12. Then 48 minus 36, that is 12. The third differences are the ones which are constant. So it means somehow our temp position is going to be cubed. So it's going to be n cubed. Now let's check n cubed. Now if you say 1 cubed, so like T1 is going to be 1 cubed. And then what do we do to get 2? We have to add 1. 1 cubed plus 1, we get 2. Or we can say, let's say T1 is equal to 1 cubed times 2. Let's see which one will work for the second one. T2 is going to be 2 cubed. 2 cubed plus 1, we get 9. So this one is out. Let's try this one. Then T2 is equal to 2 cubed, which is 8 times 2. We get 16. This one seems to be working. Let's check T3. T3 is 3 cubed, which is 27. 27 times 2 is equal to 54. Okay, this one is working. T4 is equal to 4 cubed times 2. 4 cubed is 64. 64 times 2 is 128. So it means you have to cube the position number and then multiply it by 2. We have to cube n and multiply by 2. Therefore, Tn is equal to 2 times n cubed. So you can write Tn is equal to 2n cubed. And then the question it said, find the sum of the numbers in the 8th row. So what is T8 now? T8 for this sum is going to be 2 times 8 cubed, which is equal to 1024.